Hi students, I am Dr. H.S. Wankhede. Today we are going to learn the learning concepts of the Bayesian learning. As we have knows that there are many types of machine learning algorithms, and Bayesian learning is one of the mostly used learning algorithm in the machine learning applications. These are the topics we will discuss today. First one is role of the Bayesian method. Is there are many methods, many learning types also what we have discussed in our means previous sessions or earlier sessions what we have uh, discussed the three types: the supervised learning, unsupervised learning, and the reinforcement learning. So like means decision tree or the artificial neural network methods used in the machine learning applications. Likewise, Bayesian learning is one of the method mostly used in the machine learning, and why it is means useful, that we will discuss. Then the actual Bayes theorem, what is it? Actually, this learning is based on probabilistic means yeah, probabilistic methods, and how means it is related with the concept learning. So concept learning also we have discussed in our means previous discussions. Now the roles of the Bayesian method. The Bayesian method provides the probabilistic approach to inference. Whatever be the prediction, what we want, what we expect from the model, that we can predict, that we can calculate on the basis of the probabilistic approach. It is based on the assumptions that the quantities of interest are governed by the probability distributions, and the optimal decisions can be taken by the probabilistic data and the reasoning about this probabilistic data and the with the observed data. It is means as I told you, it is important in machine learning. Why? Because it provides the quantitative approach and the means evidences of the supportive alternatives. This reasoning, means Bayesian reasoning, provides the basis for learning algorithms that directly manipulate the probabilities. So means we have some prior knowledge, means the prior probabilities, then we have the data, and then we will calculate the posterior probabilities. So it provides somewhat the framework for analyzing the operations of the other algorithms also. Means we have seen uh, some algorithms, some methods like decision tree algorithms, and the artificial neural network methods for the machine learning. So in that also we can use the probability, we can use the Bayesian methods. Now, how it is different from the other learning algorithms? Say, for example, generally what we do, if n number of means data is there, then in this learning, what we do basically, the data which is not suitable, or means if it is uh, fail to means fulfill the criterias what we have said, generally we exclude that data. We didn't check the probability, means sometimes if bias data is there, then that data we exclude. But in probability we consider that data also, if it is means not used, but we can calculate the probability. How means how much percent it is useful for training the means model. The Bayesian learning methods are somewhat relevant to our the study of machine learning for two different reasons. What are those two different reasons? The first one, Bayesian learning algorithm that calculates the explicit probabilities for the hypothesis. Say for example, in naive Bayes classifier, the most practical approaches to certain type of learning problems. The one researcher, Mikey, provide some sort of data, and the research, and claims that the naive Bayes classifier is competitive with the learning algorithms like decision tree or the neural network algorithms. In many cases, and in some cases it outperforms the other methods. So in this lecture we will discuss the naive Bayes algorithm. The second reason why the Bayesian methods are important is that the Bayesian methods provides a useful perspective for understanding many learning algorithms that do not explicitly manipulate the probabilities. We can also use the Bayesian analysis to justify a key design choice in neural network learning algorithms. We use Bayesian perspectives to analyze the inductive bias of the decision tree learning algorithms also. There are some features of the Bayesian learning methods. And what are these features? These features are in every observer training example, there can be incrementally decrease or increase the estimated probability that a hypothesis is correct. This provides the more flexible approach to learning than algorithms that completely eliminates the hypothesis if it is found to be inconsistent with any single example. The second feature is that the prior knowledge can be combined with the observed data to determine the final probability of the hypothesis. So in Bayesian learning, prior knowledge is provided by asserting either by the prior probability of each candidate hypothesis or the probability distribution over observed data for each possible hypothesis. The next feature is Bayesian methods can accommodate hypotheses that make probabilistic prediction. Say for example, the hypothesis such as, suppose now COVID patients, nowadays it is means everyone is facing the difficulties, and if someone unfortunately means suffered or infected by the COVID, then the COVID patient has how many percentage chances of the recovery. So this is one type of example. The doctor can say probably means 80% chances, 90% chances, like that. The next feature is the new instances can be classified by combining the predictions of multiple hypotheses weighted by their probabilities. Even in cases where Bayesian methods prove computationally intractable, they can provide a standard of optimal decision making against which other practical methods can be measured. So these are some features of the Bayesian learning methods. Which can be used for the machine learning models. There are some difficulties also with the Bayesian methods. What are those difficulties? The practical difficulty is that if we want to apply the Bayesian method to any means the problem what we have defined and all, so we must have the initial knowledge of many probabilities. Why? Because means as I told you, the prior probabilities is there, then data set is there. On the basis of the prior probabilities and the data set, we will calculate the posterior probability. That posterior probability also can be means applied. So as a prior probability for the new data, then on the basis of that again we will calculate the posterior probabilities. So these three are the means main factors here: prior probability, data, and the posterior probability. So this is means practical difficulty with the Bayesian method if we means implement to solve the machine learning problems. But sometimes it is not means possible that we have the prior knowledge or the prior probabilities. Then what we have to do? If it is not known in advance, then we have to estimate based on the background knowledge. So what is the available data, then assumptions by the experts and all, we will create the uh, prior knowledge or the initial level knowledge. The second practical difficulty is that the significant computational cost required to determine the Bayes optimal hypothesis in general case. So in some certain specialized situation, the computational cost can be significantly reduced. So this is related to means Bayesian method and the features of the Bayesian methods and how means it is useful other than the decision tree and the uh, neural network methods. Now Bayes theorem. So as means you are looking this slide, so there is one probability equation. Generally in machine learning we are interested in determining the best hypothesis from the sample space. So probability of space means that is hypothesis, H is the prior probability of the hypothesis, then the probability of training data. So given data, or we can say that the observed training data, then to define the Bayes theorem precisely, let us first introduce the notations. The probability of hypothesis, prior probability of hypothesis is denoted by PH. Then the probability that the training data D will be observed and denoted by the probability of data. Then the probability of the hypothesis on the basis of the given data, and the probability of the data, observing data, in which the hypothesis H holds. So this is the equation of the Bayes theorem. The probability of hypothesis on the given data, it is called the posterior probability. It is called the posterior probability, and the probability of hypothesis is the prior probability, and also the probability of training data or observed data is also the prior probability. So these are the prior probability, and the probability of hypothesis on the given data is, we have to calculate which is the posterior probability. So these are the notations and the equation of the Bayes theorem. Yes, H map. Through this equation, we will calculate the hypothesis of a maximum of posteriori hypothesis H. Okay, we will discuss this complete case in the next lecture. Till now, just you study the probability equations, and you need to understand how the Bayesian learning is useful in the machine learning techniques. So there are two questions what we have discussed today. The very first one is, what is Bayesian learning? So you take some time and think on it, what we have discussed in the beginning of today's lecture, and how it is useful in machine learning. So these two questions we have to we must be able to answer these two questions in this lecture. So thank you very much. We will continue the remaining part in the next lecture.